In the previous lecture, you explored how to secure autonomous artificial intelligence agents, where the central challenge is controlling actions, limiting blast radius, and ensuring accountable autonomy. Now you move to the enterprise reality that determines whether your security architecture can scale. Integrating artificial intelligence security into cloud security and the security operations center. Artificial intelligence security cannot exist as a separate specialty disconnected from your existing security operations. If artificial intelligence workloads are deployed in cloud environments and integrated into business workflows, then the security telemetry, detection logic, and response processes must flow into the same enterprise systems that already defend your organization. This session will help you align artificial intelligence security with cloud-native application protection platforms, security information and event management platforms, extended detection and response platforms, and security operations automation. You will also learn how to position well-known tools such as Microsoft Defender for Cloud, Microsoft Sentinel, Splunk, and CrowdStrike within an integrated architecture. Before you discuss specific tools and platforms, let us set the context for why integration matters. In early artificial intelligence adoption, organizations often deploy models as isolated pilots. A small team monitors the system manually. Issues are handled through informal processes. That approach does not scale. When artificial intelligence becomes embedded across enterprise workflows, you must treat it like any other critical production workload. It must have standardized telemetry. It must be monitored continuously. Alerts must reach the security operations center. Incidents must be triaged consistently. Response must be orchestrated across identity, cloud, endpoint, and application layers. If artificial intelligence security remains outside these processes, you will face two outcomes. You will miss incidents because alerts are not connected to operational workflows, or you will detect issues but fail to respond effectively because the security operations center lacks context. Integration is not an optional enhancement. It is the foundation of operational readiness. Now that you understand why integration is essential, let us begin by mapping artificial intelligence workloads to cloud security visibility. Artificial intelligence systems often run on cloud infrastructure such as compute clusters and accelerator hardware, container platforms, managed model hosting services, storage accounts that hold training data, vector databases, and search services, application programming interfaces exposing model access. Each of these components generates security-relevant telemetry. As an enterprise architect, your first task is to ensure that artificial intelligence workloads are treated as first-class workloads within your cloud security monitoring framework. This includes asset discovery, configuration assessment, vulnerability visibility, and risk scoring. If you cannot see the workload, you cannot secure it. Now that you know where artificial intelligence workloads live, let us align them with cloud-native application protection platforms. A cloud-native application protection platform brings together posture management, workload protection, and risk visibility across cloud environments. In this context, your goal is to ensure that artificial intelligence workloads appear as monitored assets with clear security posture signals. This may include misconfiguration detection for storage and compute resources, identity and access misconfiguration detection for model endpoints, vulnerability assessment for container images used in model serving, workload protection signals for suspicious activity in model hosting environments, configuration drift detection for infrastructure supporting model pipelines. Microsoft Defender for Cloud is commonly used to provide cloud posture and workload protection across cloud resources. From an architectural perspective, you should ensure that any resource supporting artificial intelligence pipelines is onboarded and monitored consistently. You should also ensure that security posture findings can be correlated with artificial intelligence risk classifications. For example, a high-risk artificial intelligence use case should have stricter posture baselines and tighter control thresholds. Now that you have visibility, let us discuss how security events become operational. Security information and event management. Security information and event management platforms centralize logs, correlate signals, detect threats, and generate incidents for triage. If artificial intelligence security signals do not flow into security information and event management, the Security Operations Center cannot see them. Artificial intelligence relevant signals may include anomalous query volume to model endpoints, repeated prompt injection attempts, suspicious retrieval patterns in retrieval augmented generation systems, unauthorized access attempts to training data repositories, model extraction style behavior patterns, tool execution anomalies from autonomous agent systems. Microsoft Sentinel and Splunk are examples of platforms that can ingest logs and telemetry, correlate events, and create incidents. From an architecture perspective, you must define log sources and log standards. You must decide what to log at minimum, user identity and authentication context, request metadata and risk indicators, retrieval source identifiers and access decisions, tool call events and approvals, output policy violation indicators, model version identifiers. Without structured logs, detection is weak. Without detection, governance and assurance collapse. Now that you understand centralized detection, let us align artificial intelligence security to extended detection and response platforms. Extended detection and response integrates telemetry across endpoints, identities, cloud workloads, email, and applications to detect coordinated attacks. Artificial intelligence systems are not isolated. Attacks against them may involve compromised endpoints used to query models, stolen identities used to access model interfaces, cloud resource exploitation to modify pipelines, data exfiltration through storage accounts feeding training systems. Extended detection and response platforms help correlate these signals across domains. CrowdStrike is widely used for endpoint and threat hunting capabilities, while broader extended detection and response ecosystems may integrate identity, cloud, and network telemetry. From an architecture perspective, the goal is correlation. If a user identity shows suspicious activity on an endpoint and simultaneously queries a large language model with extraction-like patterns, you want the system to connect those dots and raise the severity. Artificial intelligence security becomes more effective when it is correlated with broader enterprise attack signals. Now that you understand detection and correlation, let us move to the next evolution: automation. Artificial intelligence driven automation is transforming how security operations centers operate. Automation can help enrich alerts with context, summarize incidents quickly, recommend response actions, perform safe containment steps under defined rules. However, automation introduces risk if it is not controlled. You must apply the same principles you use for autonomous agents. Automation must be scoped. High impact actions must require approval. Execution must be monitored and auditable. In an enterprise architecture, automation should be designed in tiers. Low risk actions can be automated fully, such as enrichment, tagging, and routing. Medium risk actions can be automated with human approval, such as disabling a user session. High risk actions should require explicit authorization, such as isolating critical systems or blocking entire network segments. Artificial intelligence driven security operations center automation becomes powerful when it is governed. It becomes dangerous when it is uncontrolled. Now that you understand the functional alignment, let us position the tools mentioned in this lecture within a coherent enterprise architecture. Microsoft Defender for Cloud supports cloud posture management and workload protection, providing a foundation for monitoring cloud resources that host artificial intelligence pipelines and model endpoints. Microsoft Sentinel supports security information and event management and orchestration, enabling log ingestion, correlation, incident creation, and response workflows that include artificial intelligence relevant telemetry. Splunk provides broad log aggregation, analytics, correlation, and threat hunting capabilities, enabling security teams to analyze large volumes of telemetry, including artificial intelligence interaction signals. CrowdStrike provides endpoint detection, response, and threat hunting capabilities, contributing to cross-domain correlation when attacks involve user devices and identities interacting with artificial intelligence systems. As an architect, your responsibility is not to choose a tool brand first. Your responsibility is to design the integration architecture so that whichever tools you use, the signal flows remain consistent, auditable, and actionable. Now let us ground this integration approach in a realistic scenario. Imagine your organization deploys a retrieval augmented generation assistant connected to internal policy documents and operational procedures. An attacker compromises a user account and begins probing the assistant with prompts designed to extract restricted information. At the same time, the attacker attempts to inject malicious documents into the knowledge repository to influence retrieval outputs. If you have integrated artificial intelligence security into your cloud and security operations center architecture, several things happen. Cloud posture monitoring detects suspicious changes or unusual access to storage accounts. Security information and event management correlation detects repeated injection attempts and abnormal retrieval patterns. Extended detection and response correlation links the suspicious activity to endpoint behavior and identity anomalies. Automation enriches the incident with context, including model version, retrieval source identifiers, and access decision logs. The Security Operations Center triages the incident quickly and applies response actions aligned with governance policy. This is enterprise readiness. Without integration, these signals remain isolated, and the incident may go undetected until major exposure occurs. Now that you understand the architecture, let us elevate this to leadership thinking. Security architecture is successful only when it is operable. Operable means the Security Operations Center can detect and triage incidents. Logs are standardized and accessible. Alerts are meaningful and prioritized. Response playbooks exist and are practiced. Governance has visibility through dashboards and evidence. Leaders should demand measurable assurance that artificial intelligence security is integrated into daily operations. If artificial intelligence security remains a side project, it will fail at scale. When it is integrated, it becomes part of enterprise muscle memory. Now that you have explored how to integrate artificial intelligence security into cloud security and security operations center operations, let us summarize the most important insights from this lecture. Artificial intelligence security must integrate into cloud security and security operations center processes to scale beyond pilot deployments. Artificial intelligence workloads must be visible as first-class assets within cloud monitoring. Cloud-native application protection platforms provide posture and workload protection signals for artificial intelligence infrastructure. Security information and event management platforms must ingest artificial intelligence logs, correlate events, and generate actionable incidents. Extended detection and response correlation strengthens detection by linking artificial intelligence threats with endpoint, identity, and cloud telemetry. Artificial intelligence-driven security operations center automation can accelerate response, but must be scoped, governed, and auditable. Tools such as Microsoft Defender for Cloud, Microsoft Sentinel, Splunk, and CrowdStrike can support different layers of this integrated architecture. Integration turns artificial intelligence security from isolated controls into operational readiness. Now that you understand why integration is essential for enterprise scale artificial intelligence security, Reflect on your organization. Are your artificial intelligence workload visible in cloud security posture management? Are artificial intelligence interaction logs flowing into your security information and event management platform? Can your security operations center triage artificial intelligence incidents with confidence? Is automation governed and auditable or uncontrolled? If this lecture strengthened your enterprise security architecture mindset, subscribe to the channel so you do not miss the next session. Like this video if you believe artificial intelligence security must be operational, not theoretical. And comment below with your perspective. Is your organization integrating artificial intelligence security into cloud and security operations center workflows? Or are deployments still happening without operational readiness? Let us build secure, resilient, and enterprise-ready artificial intelligence security architectures together.